And finally exercise 8, the last exercise of this section. And here, as we said in the previous video, we are going to see what we mean by a completion of a metric space. This exercise has several parts. Today we are only going to see part A. So let's start with the metric space x comma d. Now what we are going to do, in this metric space, say xn is any Cauchy sequence. We are going to attach a symbol, a formal symbol to this sequence. And we are going to call that formal symbol the formal limit of this sequence. It's a new object, okay, and it's written like this, capital LIM xn. This is not actually the ordinary limit of this sequence, which may or may not exist in this space. Okay, the sequence may or may not be convergent in the space. Recall that every convergent sequence is Cauchy, but every Cauchy sequence is not necessarily convergent. But anyway, we attach this symbol to this sequence. And then we define an equality relation on the set of such symbols. For two Cauchy sequences xn and yn, we say that their formal limits are the same. If, this is a definition, okay, if this happens, that is, if you consider the sequence of distances between corresponding points or corresponding terms of these two sequences, xn and yn, then this dxn comma yn, this is a sequence of real numbers. If this sequence converges to 0, then we say that the formal limits are the same. And now we have to show in this part that this definition of equality between formal limits satisfies or obeys reflexivity, symmetry and transitivity. And that's why it becomes a legitimate definition of equality. Solution, and the very first line is just this: reflexivity and symmetry are obvious. They are really obvious. You think for yourself why. Next we go for transitivity, for which we have taken three Cauchy sequences xn, yn and zn in our space X, such that the formal limits of xn and yn are equal and the formal limits of yn and zn are equal. Which just means this, that the sequence dxn, yn converges to 0 and the sequence dyn, zn also converges to 0. So from limitless for sequences of real numbers, the sum of these two sequences also converges to 0. This limit is also 0. Now next to consider these inequalities. For any positive integer n, that means for any index n, the distance between xn and zn of course is greater than or equal to 0 because we have metric. And by triangle inequality, that is less than or equal to the distance between xn and yn plus the distance between yn and zn. So you now see that you have a sequence of real numbers which is trapped between two sequences, one of which is the constant sequence 0 and the other is this sequence which also converges to 0. The constant sequence automatically converges to 0. So you can apply the squeeze test here. So by the squeeze test, this middle sequence also converges to 0. But then by definition, the formal limit of xn is equal to the formal limit of zn. And that means that our definition of equality of formal limits is transitive too.